Hi, it's Mr. Kane here, and we're going to introduce you to the two different types of circuits we can create in electricity, and also what happens with current and voltage in those circuits. Now, when you've been busy messing around with the electrical practical equipment, you've probably already created these two circuits, whether you intend to or not. We've got series circuits where things are connected one after the other, just one sort of complete line of path for the electricity to flow through, or we've got parallel circuits where there's alternate pathways that the electricity can take. Have a look at how these two light bulbs are connected in these two circuits and you'll see what I mean. Also, while we're here with these two pictures side by side, take note of how bright the bulbs are glowing. We can see that in this circuit both bulbs are on, but in this circuit they're much brighter. That'll be important later on. So a series circuit, the components are connected just one after the other. End to end, one follows the other. So it's a simple loop for electricity to flow around, and if one bulb blows, so for example, if this bulb was to stop working, that means electricity flow is stopped. It cannot get past that point there, and both bulbs go out. However, in a parallel circuit, we've got alternate pathways. Things are connected side by side. So we can see here in the diagram, it's probably a bit easier to see from the circuit diagram than it is from the picture. We've got two separate pathways, and the current's got a choice of where it can go. So if, for example, this bulb was to blow, current would stop here, but it can still go through this pathway here. There's still going to be a light bulb alight. This is how the lights in a house are wired up. So if one bulb goes, you don't end up in the dark. So let's look at current in these circuits, the speed of how fast the electrons are flowing past a certain point. How fast? So we use a ammeter to measure that, and that's the symbol for an ammeter there. And we join this into the circuit in series. Just plug it in as another component. So series circuit, in it goes. We could put it in between the bulbs. We could put an ammeter here, or we could put it here. Anywhere in the circuit would do. In a parallel circuit, same deal. We put it in series. So we could put one in here as well if we wanted to, or it could go over here, just as long as it's put in series. So what happens to our current? So in a series circuit, it's the same anywhere. So here I've got 2 amps anywhere I put it. The cell is putting out 2 amps of current, and anywhere in the circuit it's going to be 2 amps. It's got to go through everything. So the speed is the same at all points. In a parallel circuit, however, the current is shared between the components. So if my cell puts out 2 amps, then it gets shared between the two pathways. If I was to add an extra pathway in, then I'd have to share it out equally, and whatever 2 amps divided by 3 is would what it would be add up to. So in this situation here, let's say if I didn't have 2 amps, I had 3 amps, then each of these pathways would get 1.5 amps of current. If I had that extra pathway, and I had 3 amps, then this pathway had 1, this would 1, and this would 1, and over here this would also be 3 amps. The current that comes out of here gets shared equally between whatever pathways that we have. What about voltage? What's that? So this is sort of the oomph or the push that the cell gives the electrons. It's measured in volts, so it's sort of the energy that they carry around with them. We use a voltmeter to measure that with, and that's the symbol for voltmeter there. So different size cells produce different voltages. You might see 1.5 volt batteries, 5 volt batteries, 9 volt batteries, 12 volt batteries. So the bigger the voltage, the bigger the oomph behind each electron in the current. And unlike an ammeter, a voltmeter we connect in parallel. We connect it across the components. We wanted to measure the voltage difference before and after the component. We sometimes call that potential difference, the difference between before and after any component in a circuit. So what does that look like? So in a series circuit, there's a voltmeter connected across a light bulb. So we've got to connect it in parallel. So we could connect one here across here, or we could connect it across here. It goes across the component. If we go here and put a voltmeter in here, there's no component here, so there's nothing to measure. So it goes across the component. Parallel circuit, same thing. Wherever the component is, we just connect it across it as if it was an extra parallel component. So what happens to the voltage in a series circuit? It's shared. So the oomph given out by the battery, in the case 3 volts, is shared equally between the components. So if I was to add in an extra bulb, if I add an extra bulb in there, that would mean this one will get 1, this one gets 1, and that one gets 1 volt. So it's shared equally between all the components. The parallel circuit, it's the same everywhere. Because we've got alternate pathways, all the oomph can go through each pathway. So all the 3 volts can go through either of those pathways. So let's summarize all that. So series circuit, parallel circuits. Continuous end-to-end loop in a series circuit. We've got a choice of pathways in a parallel circuit. They're joined side by side. The current is the same at all places in a series circuit. The current is shared out between the pathways that we have in a parallel circuit. The voltage is shared between components in a series circuit, but it's the same in all parts of the parallel circuit. There's your ammeter, and that's sort of the speed of the flow of the electrons around the circuit. There's your voltmeter, and this is how much energy or oomph or push is given to the electrons in the current, and it's measured in volts. And that's our little summary, or that's all about circuits, series and parallel, and what happens with the current or amps and the energy or voltage in the circuit. I hope it's been helpful. Thanks for watching.